Our next practical is to implement stack data structure using C. So before going to explain the program, we should know what is stack, right? Okay. So stack is a linear data structure which follows a particular order in which the operations are performed. Okay, so it is an ordered list in which insertion and deletion can be performed only at one end, that is called top. Okay, and it is a recursive data structure having a pointer to the top element. Stacks are sometimes called as LIFO lists. That means it stack order may be followed either in the LIFO order, that means last in first out order, or philo, that is first in last out order. Okay, so let's consider the LIFO order, that means last in first out, that is the element which is inserted first in the stack will be deleted last from that stack. Okay, and in stack, while insertion operations is performed, it is called as push operation, and while the removal of operations performed, that is called as pop operation. Okay, here look at here. This is the stack. One by one element is pushed into this stack. That means insertion. Insert first element, second element, third, fourth, in this way. And while removing the element, it is from the top. Okay, first this element, next this element. That means last in first order, first out order has been followed here. Okay, because this element is inserted first, right? But while removing this element is deleted from this stack at the last. Okay, now basic operations on stack, two primary operations are there, that is I have already discussed, push and pop. And another operation, that means we need to check the status of stack while we add a element, add an element to the stack. Okay, so first one is full function, which is used to check if the stack is full or not. Is second is empty function, that is used to check if stack is empty or not. And third one, peek function, which is used to get the top data element of the stack without removing it. Okay, now let's talk about how the push operation works. Okay, so while we need to insert a new element to the stack, first we need to check if the stack is full. If the stack is full, it produces an error and exit from that. If the stack is not full, it increments the top to point next empty space, okay, and adds data element to the stack location where the top is pointing, and it returns success. Let's have a look. here. First, we need to check the stack is empty or not. This stack is not empty, and top directs to the empty space, right? So top increment by 1 here, top increment by 1, it points to this empty space, and this new element, that is here it is E, data element, is inserted to this position. Okay, I hope everyone is understood how this push operation performs. Now pop operation. Okay, so how this pop operation perform? So basically pop function is used to remove data element. Okay, so first it checks if the stack is empty or not. Okay, if the stack is empty, that means no need to remove wing. No, that means no elements are there which is to be deleted, right? So it produces an error or exit. Next, if the stack is not empty, then the data element at which the top is pointing, then the top is decremented by 1 and return success. Let's have a look here. Here. First, stack is not empty, right? Stack is full. Top, first top is pointing to here. While popping out one element, top is decremented by 1, that is pop now pointing to this position, and from here E is removing and this space is empty. In this way, one by one element is popped out from this stack. Okay. Now let's discuss the program. Here, first here, look at here. Integer max size. One variable is max size, that is 8 element. Stack is 8 element, and initially top is -1. That means stack is empty. Top is -1. That means top pointing no element. First is empty function. Look at here. If top equals to -1, that means if that is empty, right? Stack is empty, it returns 1, else it returns 0. Next is full function. If top equals to max size, that means the topmost element, that is 8th element, right? It returns 1, else it returns 0. And if peak function, it gives stack top. Okay, that is, it gives the topmost element. Now pop function, while calling this pop function, what happens? First data, it gives the data, then it checks the stack is empty or not. If the stack is not empty, then it is top is decremented by 1 and it gives the data. Okay. Next, look at here. While performing with the calling this post function, it is first it is to check that the stack is full or not. If it is not full, then that means there is a space to insert an element, right? So top is incremented by 1 and then the data is inserted to that space. Okay, here main function. So push 3, that while pushing the third three element. That means it calls here this push function, and this loop, this if condition is checked. Okay, in this way this push 3, 5, 9, in this way all these elements are pushed, that is all these elements are inserted into the stack. After inserting this sixth element, what is to be done? Element at the top of the stack, that is peak. Now peak function is called. While calling this peak function, that means what is to what? The control comes where? This here. It returns stack top. Okay. So here what is the top value? Definitely the top value is 15, right? Because first 3, then 5, 9, 1, 12, 15. So now the top pointing to this 15th position, 15th value. Okay. Next, printer elements. All these elements are prints here. Now, while print that stack data, if empty function is not full, then pop, calling pop function. Okay. Next, stack is full. When is full function, if stack is full function is true, then it returns false. And if is empty function is true, it returns false. Okay, either both returns 0. Let's run this program. Yeah, look at here. So first top element 15, then the all these elements in this way, right? Because first 3, 5 in this way. Stack full, false, because here pop all function has been done. All these elements popped out. Okay, that means okay. I think this program is clear. Okay, so in this way the stack has been done.